Let's move on to page 76 and do just a few of the guided practice problems before we move on to some independent practice. Number 1, name the angle below in 4 ways, then classify it as acute, right, obtuse, or straight. Remember that we can name this in 4 different ways. We can name it DEF, angle DEF. We can name it angle FED. Notice with both of these labelings, the vertex E is in the middle. That's got to be there. It's very important. That's the number 1 most important criteria when you're naming an angle, is to include the name of the vertex. We've got angle E. And finally, because this angle is numbered, which is not typically the case, it is in this case, we can call it angle 2. And that's just to let you know that at times we can name angles by their number if they include one. Let's move on now to number 2. Number 2 is a very important problem because it includes an algebra equation. You have to remember how to solve an algebra equation to solve the problem, to find what the value of x actually is. And we do know, fortunately, that because we learned about vertical angles and what I like to call opposite angles, that 100 degrees is the measure of this angle. Well, 100 degrees is also the measure of this angle because these are opposite of each other. They're called vertical angles, and we know that they have to be congruent. Okay, a little symbol for congruent. Okay? And because that's so, we can set up an equation to solve. I can take the expression 2x plus 4, because I know this equals 100, since I'm using the laws of vertical angles, I can just simply put equals 100, and now we can solve this equation. Now let's go into how to solve an equation real quick. We'll be doing a little bit more of this when we review with our independent practice. Just remember though that the object to solving an equation is to get the variable all by itself. So at the end of the day, I want this guy, this x that I've just highlighted, to be all alone down here. I want him to equal a certain number, and that number is going to be the value of the digit that goes in for that variable. We can also, of course, check our work when we do this. So one of the best things about equations is that once we find an answer for x, we plug it back into the original equation to check it. And if we're right, we see that almost immediately. All right, let's go ahead and solve this equation. Now, when we solve equations, just to remind you, we're always working backwards. We're using opposite operations to solve and to get the x to be isolated, to isolate the variable. The first thing you always want to do when solving an equation is to eliminate the addition or subtraction. In this case, we're adding 4, so I want to think about the opposite of adding 4, which would be to subtract 4. I do that from one side, and because this is an equation, because both sides have to remain equal, I have to do the exact same operation to the left side. Now 4 minus 4 is 0. That allows me to cancel that out. 100 minus 4, that's going to give me an actual numerical answer. 100 minus 4 is going to give me 96. I'm going to drop the 2x down because I still have 2 x's. I want to know what just one of them is, remember, not both of them. So now I'm going to again work the problem out going backwards. If x is being multiplied by 2, I'm going to think about the opposite of multiply, which is to divide. And I'm going to divide both sides by 2 to get my answer. 2 divided by 2 is 1, and that's exactly what we want. We want 1x, and there it is right here. There's my 1x that I want left over. Now I'm going to divide 96 by 2, and when I do that, I get 48. So the value of x is 48. Now remember what I said earlier, we can check this work. I can now take 48 and plug it back into this expression. Remember, we know that this angle has to equal 100 degrees because its opposite angle equals 100 degrees. And if I plug 48 back into my original expression, plug that 48 in for x, and then solve, 2 times 48 is 96. 96 plus 4 is, in fact, 100. So we checked it. We know it's correct. And we'll be doing a few more of those for practice in the independent practice section. Let's move on to number 3. Number 3 says to identify a pair of vertical angles and adjacent angles on the railroad crossing sign, and then to justify your response. All right, well, let's see. A pair of vertical angles We've got angle 3 and angle 1. We've got angle 2 and angle 4. For our adjacent angles, remember adjacent doesn't mean straight across from, it means right next to. So whereas vertical means across from, adjacent means right next to. So here we've got 2 and 3. We've got 3 and 4. Now I'm only going to put 2 down, but you can see there are several more adjacent angle pairs. 4 and 1, 1 and 2, okay? And as far as justifying our response, well, I think we did that just in the explanation. We know that 2 and 3 are adjacent because they are next to each other. Back all these angles. Oops. Because they are next to each other. Okay. Let's move on to page 76. Now, I went ahead and just put this answer here. These are really, really good notes when we're just comparing the differences between vertical and adjacent angles. We've been talking about it a lot, but I do want you to go ahead and get this down. That's going to conclude the notes part of this section. We're going to move on here soon to doing some independent practice on your own, and then we'll review that. So go ahead and get this down. If you need to pause it to take your time, get it down, and then we'll be moving on to part 3 of the lesson, which is to do the independent practice and then to review it.